This lesson is to show how to think about the range of the two functions secant t and cosecant t. So we've already talked about domain. That's what values can go into these two functions. And the range of a function is just what values can come out of it. So just as a quick review, since secant t is 1 over cosine t, the domain is just all values of t that don't make the denominator 0. So when I think about what doesn't make the denominator 0, I have to think about, well, what does make the denominator 0? And the denominator is 0 when x is 0, here and here. So t cannot be pi halves or any half rotation away from pi halves. Similarly, since cosecant of t is 1 over sine t, the domain is any value for t that does not make sine equal to 0, and sine t is 0 at any multiple, integer multiple, of pi. So t cannot be an integer multiple of pi. But the range we have to think about a little bit differently, because the range is what comes out. And so t goes in. For example, with secant, a value goes in, you evaluate the cosine, and then you take the reciprocal. 1 over cosine just means the reciprocal. So what I'd like to do is look at some reciprocals of different values that cosine could be. And remember, both cosine and sine, their values, their ranges, their values that they can be range between -1 and +1. So except for at the 0 or at the two endpoints, -1 or +1, we're talking about a fraction. So, might be written as a decimal, but we're talking about a fraction. So I'm going to look at different fractions. So let's say that cosine of t equals 1/2. And this is a special value, so I could actually look at what values for t make that happen, but I'm not so concerned about that. What I want to look at is what happens when I take the reciprocal. What is 1 over 1/2? And what you get is 2. So let's try another one. So let's say we found a spot where the y-coordinate, where the terminal side of the angle landed, the y-coordinate was -1/5. So this is certainly possible. Y-coordinate -1/5, maybe there, maybe not quite that low, but around there. Excuse me. So when I look at the reciprocal, what is cosecant of t going to be? What's the reciprocal of that fraction? What's 1 over -1/5? And that's -5. And we can see that the smaller the absolute value of the fraction is, the larger the absolute value of its reciprocal is. I could go to an extreme and say, oh, well, how am I going to get cosecant to be 10,000? Well, all I have to do is find a spot where sine of t is equal to 1 over 10,000, and all of a sudden cosecant t, which is just the reciprocal of sine, 1 over 10,000 is 10,000. So I can actually get as large as I want, positive or negative, and as small as I want, but only down to 1, absolute value 1. I'm not going to get a fraction out of cosecant or secant, because to have the reciprocal of something be a fraction, let's try that. How are we going to get the reciprocal of something to be a fraction less than 1? And I can think of something, maybe 2. If this is actually 2, the reciprocal of 2, 1 over 2, is a half. And honestly, anything, let me try this in general, 1 over some number wants to be less than 1. If I multiply both sides by x, assuming it's not 0, and let's see, I was in the wrong color, so 1 has to be less than x. Well, that's another way of saying x has to be greater than 1. So the only way the reciprocal of something ends up less than 1 is if that something is greater than 1. But sine and cosine are always less than 1 or greater than -1. I'm thinking absolute values here. I'll put all this together, and the range for both secant t and also cosecant t is anything greater than 1 or anything less than -1. So a little bit of this notation, this symbol right in the middle, it looks like kind of a U without a tail, just that stands for union. And what this says is I've got 2 pieces of the number line that work here. Anything that's a negative number whose absolute value is less than or equal to -1, -1 down, or it could be a positive number, 1 up. And that's going to be what values can come out of secant and cosecant.